Hello, and thanks for joining us today. The aim of this talk is to discuss the implications that solar radiation management, SRM, might have for the Sustainable Development Goals, SDGs. And so we're going to talk about what little we know, what the research gaps are, and what the governance needs are for avoiding risks to the SDGs from SRM. And the first question is, what's been studied so far? As you probably know, SRM is a relatively new area of study, with most research taking place in the last 10 years. And I think that we can say that the research has been pretty uneven and not centered upon the SDGs at all. In particular, I think we have a little bit of research that applies to how SRM might impact goals 2, 3, 6, 7, 13, 14, and 15, and 16. So that's not to say by any means that we can answer all or even most of our questions in those areas. I'm just saying here that there has been a study out there in the world that has touched on those particular goals. And it might just be one study when really we would need 100, because science is all about assessing a body of knowledge, not responding to a single study. And so I think we lack a knowledge basis to say much of anything with regards to the rest of these goals. But what I'm going to do now is briefly go through some of the studies we do have. First, however, I want to talk about the metrics that these studies are using. So most research on SRM is done using climate models, the same kinds of models used to study climate change. You can see in this figure the main metrics that are used to report the results of SRM modeling. So surface air temperature and precipitation are the main ones. Would SRM cool things down? Will it rain more or less in a world that's doing SRM compared to one with climate change? There's a number of metrics, though, that people can pull from these modeling studies, such as parameters related to vegetation or ocean chemistry. And the main point here is to understand that if you want to understand the implications for the SDGs, you need to translate this modeling output, which comes in the forms of these metrics and numbers, into implications for communities and human life. And so you need knowledge of the social system to do that. You need people from a wide range of expertises, including local knowledges, to get you from a set of numbers and these modeling outputs to an understanding of what happens for development, for livelihoods, for life in communities in a region. So the second SDG is zero hunger. And we know that hunger is far more than a crop productivity issue, right? It's an issue of food distribution and access, and who has the funds to buy foods on the market, etc. But crop yields are one factor in getting to zero hunger, and that's the kind of factor that can be modeled using these models. So these are the kinds of studies you get when it fits with the modeling parameters. So for example, temperature, precipitation, etc. And there's a handful of studies that have looked at this. For example, this study by Proctor and colleagues looked at the projected effects of geoengineering on several crops. And they found that the damages to agriculture were basically equal to the benefits from cooling in a mid-21st century scenario with geoengineering. It's very complex because you need to be able to understand not just the effect of changed temperatures and how that heat stress affects crops, but also changes in the sunlight and changes in precipitation and the CO2 fertilization effect, so how crops grow in a high CO2 world. So I think we can say that while there's a handful of studies that look at all those variables, much more needs to be done around the world. The third SDG is health, and this is similarly complicated in terms of weighing a bunch of factors. So for example, in terms of the direct health effects of SRM, there's been a little bit research looking at the effects of using, in particular, sulfate aerosols on air quality and exposure to UV and weighing that with changes in ozone. All of those need to be weighed against each other, and you've done mostly with modeling tools again. Then the indirect health effects, there's even more there to study, right? So how would SRM impact heat stress? Presumably it might lessen it, but what about disease transmission? And so some scientists, Colin Carlson and Chris Trizos here, have put together a framework for thinking about these health impacts and how to assess them, which involves linking public health with ecological research and doing a risk-risk assessment, weighing the risks of climate engineering or SRM with the risks of climate change. So turning to SDG 6, clean water and sanitation. There's been some studies of water availability under SRM, which again is only one component of clean water and sanitation, because access to water obviously plays a huge role there, and what governments are doing to provide infrastructure, etc. But water availability is the thing that can be modeled using these modeling tools. So they found that precipitation changes under SRM are not linear. Understanding how plants respond is an important part of understanding the changes that might happen in the water cycle. And there's a fair bit of research on this underway compared to some of the other areas. SRM and affordable and clean energy. So you might wonder, for example, if blocking incoming sunlight would affect solar power. And there's been a little bit of research on SRM and solar power availability, finding that concentrated solar power, as in this picture here, might see small reductions, but photovoltaics would not be strongly affected. And this has to do with diffuse sunlight and a lot of sciencey things we won't go into. Hydroelectric is also something that hasn't been well studied, but would be very important. Perhaps the biggest issue, from my point of view anyway, would be the social dynamics here, such as mitigation deterrence. In other words, would the availability of SRM mean that governments or companies would be less motivated to provide clean energy because they imagine that SRM could lessen the need for it? Again, we don't know, but this links very strongly with Goal 13, climate action. And the IPCC special report on 1.5 degrees does touch on this literature on the dynamics of mitigation deterrence for climate action. So they indicate that the literature shows low agreement on whether SRM research and deployment may lead policymakers to reduce mitigation efforts and thus imply a moral hazard. This is the kind of thing that's hard to study, but you can definitely speculate about it. How about marine life below water? There's some research that SRM may be able to mitigate heat stress in reef ecosystems, but ocean acidification continues. And so while there's been a few studies about the effects of SRM on the oceans, these haven't been framed in terms of sustainable development and how SRM would affect fishing communities, for example. Very little research there. Life on land, there's been at least one study that looked at what would happen if SRM was suddenly terminated, which would be very bad for species, because if SRM was suddenly shut off, then species wouldn't be able to adapt to the rapid warming that would happen. However, there's been no research on whether SRM could help species which need to migrate to new areas because their climate has changed. And there's just a whole host of basic ecosystem response questions here that haven't been explored. And finally, in terms of peace, justice, and strong institutions, there are a lot of articles on these themes, but they're largely theoretical and not empirical, because it's a speculative world to explore, right? So there's a lot of speculation on whether SRM could be weaponized or cause a so-called climate war. There's no research on whether it might support peace or reduce conflict if you're comparing it to a world with a lot of climate change, which presumably would have more conflict, exacerbate existing conflicts, etc. In terms of helping nations or others collaborate or increasing conflict between nations. What the special report on 1.5 notes is that there's robust evidence but medium agreement for unilateral action, meaning one country going it alone with SRM, potentially becoming a serious governance issue. Some argue that enhanced collaboration might emerge around SRM. There's, of course, a UN convention that would prevent the use of SRM as a weapon. That's NMOD, which entered force in 1978 and prevents the hostile use of environmental modification. But in general, governance is a big challenge here. And so, as you can see, really, we don't know that much about the implications of SRM for sustainable development. And I'm sorry if that's disappointing, but we have to be honest when we lack knowledge. And so you can see what the IPCC said in its special report on 1.5 degrees. They have a paragraph on sustainable development and SRM, and they say that there are a few studies investigating potential implications of SRM for sustainable development. These are based on a limited number of scenarios and hypothetical considerations, mainly referring to benefits from lower temperatures. Other studies suggest negative impacts from SRM implementation concerning issues related to regional disparities, equity, fisheries, ecosystems, agriculture, and termination effects. And so overall, there's high agreement that SRM would affect many development issues, but limited evidence on the degree of influence and how it manifests itself across regions and different levels of society. So there you have it from the IPCC. I will just say a little bit more about how we might fill these research gaps. And I think that one really important thing is to do research in the places that would be affected by researchers who know the landscape, because you can have a modeling result, but as to what that means for sustainable development on the ground, you need to know the local context to figure that out. And so this is from a paper by one of the researchers on the SRMGI decimals team. So that's the SRMGI is a solar radiation management governance initiative. It's a nonprofit, and one of their initiatives is called Decimals Developing Country Impacts Modeling Analysis for SRM, which is a fund that funds researchers in the developing world to do studies on what SRM might mean in their region. And so to understand the implications for sustainable development, we need locally grounded research and locally grounded interpretations of that research by communities or social scientists or them working together to understand the implications for the SDGs. Another point here is that many of the implications of SRM for the SDGs don't have that much to do with SRM at all in terms of the aerosol particles in the stratosphere. The implications have to do with the social and policy context in which SRM might be used. What's going on with climate policy, what's going on with development policy in particular areas. And so to wrap up, I'll spend the last minute talking about governance. As you may have heard, there's a number of international instruments that have some scope for looking at the interactions between SRM and the SDGs, such as the Convention on Biological Diversity, the Montreal Protocol, and a few others. None of these, however, is comprehensive. So the early needs here are for research and assessment on the questions we've discussed today, and coordinating those existing institutions to really look at these implications for the SDGs. In the midterm, however, there's some more specific research needs surrounding, for example, who might compensate for harms from SRM or provide insurance against those harms. What's the procedure for decision-making? How can it be equitable and participatory? And here I would turn to the expertise of this academic working group on climate engineering governance, which produced a report with 12 specific recommendations, starting with a commission modeled on the World Commission on Environment and Development, as well as a stakeholder dialogue. So turning to some of the things that we've used to produce the SDGs to also look at SRM. And so I recommend looking at their recommendations further. a lot of good insights there. Maybe your next starting point for this exploration, but clearly we have a lot of work to do. And I just want to thank you for taking the time out of your day to engage with this very challenging but important topic.